Welcome once again to Video Learning Uganda revision series, where we look at the revision of all subjects. And tonight we are looking at ordinary level physics, and we are on episode 2, question 8, and we want to look at the possible solution to this question. However, the question reads, state Archimedes' principle, and part B, a rubber balloon of mass 5 times 10 power negative 3 kilograms is inflated with hydrogen and held stationary by means of a string. Now, if the volume of the inflated balloon is 5 times 10 power negative 3 cubic meters, calculate the tension in the string. A good question there. And then we need some information regarding the solution of this question. We need the density of hydrogen, which is stated right there, and the density of air, which is stated right there. But in case it is not stated in the examination question paper, it is always on the first page. Please try to find these values that are needed here. In such calculations, we normally state them there. And let's see the possible solution to this question. But allow me first to remind you and be thankful to those who are viewing our YouTube channel. Please, we normally post these videos there. Please check them, and remember to subscribe such that you can always be noted when we upload a new video. Yes, state Archimedes' principle. That was part A. Archimedes' principle states that the body, when fully or partially immersed in a fluid, the upthrust on the object, we call it the body, shall always equal to the weight of the displaced fluid. Very simple. Archimedes did this experiment and proved it. So that is a principle that you can use in a number of calculations and a number of situations. When any object is partially or wholly immersed in a fluid, it will experience an upward force called upthrust. The force is called upthrust, and that force is equal to the weight of the fluid displaced. That is part A, and part B is right there. We're going to perform this calculation, but we realize that in our calculation now, we're looking at the rubber balloon of mass, that one, inflated with the hydrogen and held stationary in air by means of a string. So in this case, we shall first look for the weight. We need actually the total weight of this balloon, but the total weight of the balloon will include the weight of the fabric and also the content in the balloon, which is the hydrogen. And weight is a result of mass. We get mass and multiply it by g, acceleration due to gravity. Now that we do not have mass given for all, but we have mass for the balloon, we can begin by calculating the weight of the balloon fabric, which will be equal to the mass times the acceleration due to gravity. And the mass is 5 times 10 power negative 3, acceleration due to gravity, we shall use 10. That gives you 0.05. And then the content mass is not given, but we need to get the weight of this hydrogen, because when you get weight of the fabric plus weight of the content, you get the whole weight of the balloon. Now, weight of the content, which is hydrogen, we shall acquire mass by using its density, and of course we've been given the volume of the inflated balloon, so that is the same volume for the hydrogen in the balloon. How do we get it? We go back to our formula of density being equal to mass over volume. So if you want mass mass is the density times the volume. So density has been given, so our formula of weight of hydrogen will be density of hydrogen times the volume times acceleration due to gravity. That gives you the density, which is 0.080 times 5. That is now the volume, 5 times 10 power negative 3 times 10, which is acceleration due to gravity. That one, when you simplify, gives you a value of 0.004 newtons. So that is the weight of the balloon. But now, for us to understand this very well, I need to bring up to you the illustration of what exactly we are talking about. In this case, we are seeing that downward we shall have the tension in the string which is holding the balloon, and then upwards we have the air pushing this balloon upwards, because the balloon is floating in air. Our fluid is the air we have there. So we're having up thrust. So up thrust under equilibrium should balance the weight and the tension in the string, and we shall use that fact to get our answer that is required of us, because they require us to get the tension in the string. So the tension plus the weight of the balloon is equal to the up thrust, because we are assuming equilibrium in this case. Now, if that is the case, therefore, we need to get the total weight, the actual weight of this balloon, which will be got, as you can see. The forces I'm indicating to you there, how they are moving. Upwards is up thrust, and downwards we have a weight and the tension. Then now the total weight of the balloon is now equal to the weight of the balloon fabric plus the weight of the content, that is the hydrogen. So we have 0.05 plus 0.004, which now gives you 0.054. And now we have seen that in our calculation we are involving up thrust, but according to Archimedes states that the up thrust is actually equal to the weight of the displaced fluid. Now the displaced fluid is air, and its density is known. We are going to use its density, and the volume will of course equal to the volume of the balloon itself. So we shall use the same volume, and then we get volume times the density to give us the mass, and then we multiply mass times acceleration due to gravity to give us the weight, which is equal to the up thrust. So up thrust is equal to weight of fluid displaced, which is equal to the density of the air times the volume times g. And when we substitute, we're having the density, which is 1.15 times the volume, which is equivalent to the volume of the balloon, because we know that one very well also from the law of flotation. So the volume will be the same in that case. So we have 5 times 10 power negative 3 as volume of the displaced air on which the balloon is now assumed floating. So we multiply that one times the density of air, giving that gives you the mass, and then we have to multiply it by 10 to give you the weight, and the answer we get there is 0.0575 newtons. So now we can get back to our final calculation level and say tension in the string will equal to the up thrust minus the weight which we got. So the up thrust is 0.0575 minus 0.054, which is the weight of the balloon, and finally we get tension in the string to be 0.0035, and all these are newtons. I must say you've been very attentive and enjoyed the discussion, but for now allow me say bye from Video Learning Uganda, and please do not hesitate reaching us on those numbers that you are seeing on the screen, and also below the screen. And the best way of reaching us, please utilize the YouTube channel of Video Learning Uganda. For now, I must say bye, and we meet next time in the next discussion. Thank you very much for attending.